everybody, welcome to my channel. Today we have a very good problem for you guys. We're talking about employee import. This is a very good problem, so make sure you pay close attention to the problem, right? So it says we're given a data structure of employee information, right, including the employee's unique ID, right, and points value and direct subordinates, right, IDs. Okay, so we're given an array of employees, right, where each employee has an ID as an importance and has a list of subordinates, right? Okay. So it's a list of that, right? So you see we're given a list of employees, right? And their structure employee is defined here, which is it has an ID and a points value, right? Which tells you how important this employee is, right? And the subordinates, right? Which, or the subordinates that report to this guy, right? Okay. So that's kind of what, so we have a list of those IDs, right? We don't have a list of, a list of those IDs, right? Of those employees, pretty much what I'm saying, okay? So it says give an integer ID, right, that represents an employee's ID, return the total importance of this employee and all of their direct and indirect subordinates, right? So pretty concise and good problem statement, right? I like it. So let's further, solidify the ask, right, by going through those examples here, guys, right? So you can see we're given an employee ID list, right? And an ID as well, right? So for this ID one, right, we need to return the points value of it, right? Okay, 5, right? And all of their direct and indirect subordinates, right? So 5 would return also one ID 1, right? Employee ID 1 return 5 plus the sum of all of his subordinates as well, right? So he has a subordinates here, right? This subordinate is 3, ID 2, importance of 3 added to the sum. And then it has also another subordinate right there, right? Which is also an importance of 3. So it becomes 11. 5 plus 3 plus 3 equals 11, right? And this one very similar, but this time it's ID 1, right? ID 5, right? So since ID 5, right, so ID 5 does not have any subordinates, right? So we return negative 3 because that's the only we're only going to include this guy itself, right? Because it has no subordinates, right? So that's what we return that, right? So how do we go ahead and solve this problem, guys, right? Okay. So this kind of looks like a tree pretty much, right? And we can pretty much kind of treat it as a tree and, keep in mind the algorithms that we know, right, to solve this kind of problems, guys, right? Yeah, so it's kind of, that especially the hierarchies, like, represented well with a tree structure, right? So given this, guys, right, and given a particular node, right, we just need to find a way to, capture the importance of that particular node and all of their particular subordinates as well, guys, right? Okay, so that's kind of what we need to come up with. Okay, so once we have that node, right, we know this the node that which is with the particular ID, right? We can just choose a tree, or we could explore by doing a there's a couple traversals that we know breadth first search, depth first search, right? We could choose whichever one. We're going to be choosing the depth first search because it's cleaner, right? So we would go ahead and start exploring, guys, right? So we have this node, we get the importance of 5, right? And then we can continue to recursively check all of our subordinates, right? To see to get all of their importance as well, right? And they will return that to me, and then I'll add it to my running sum, right? And then I will return that to the caller, right? So it will start like that. So for that particular node, we just check, right? We have a list of subordinates, right? So we know which node that we need to visit, right? So we visit all of our subordinates, right? So we get the running sum, originally would be 5, right? Okay, we add 5 to the sum, right? And then we go ahead and explore the first employee that we need to explore, right? ID of 2. We go ahead and explore that guy, and then after we check its endpoints, right, 3, and then we check does it has any subordinates, right? It doesn't. So we just return the 3, right? And then at this level we add 3 to our sum, right? Now we have 8, and then we visit this guy, right? We get the importance of 3, and then it has no subordinate. It returns 3 this, right? Then now it's 8 plus 3 gives you 11, guys, right? It's as simple as that, and this still be the same logic, right? We will start visiting there, guys, right? We don't need to visit one, right? Because that's not important, right? So we just need somehow to have to get reference to that node, guys, right? And once we have reference, we could start doing exploration by going down, right? Uh, so as you can see, right? So the code will be just like that, guys. As easy as that, right? But there's a little bit of things that we need to take care of before we do that, right? So the visually it looks like that, right? But the data that we're giving, guys, right? It's not given to us in a way that it contains pointers to those employees, right? So like a tree normally would, right? It's a list of integer, right? Which it's a list of those IDs of those employees, guys, right? So we don't actually have reference to those guys, right? So there's a couple ways you could do it, right? We could, it, originally, right, just do a linear loop, find the chosen employee, right? Find the chosen employee index, right, where the ID with the employee ID, right, equals to the ID that's chosen, right? So for example, right, it just happens to be the first one here, guys, right? So we would get this guy, right? This guy would be the chosen one, right? But we have to do a linear loop to find which employee or which index contains that employee with this particular ID, right? So once we find that, right, we can start the exploration. So we start the exploration, right? Okay, we start 5, and then now we have a list of integers, right? And the integer is, so now I need to visit 2, guys, right? Okay, it's not index 2, right? It's the node, right? The employee with the ID of 2, guys, right? How do I get reference to that, right? So that I can know its importance and also visit any subordinate that I need to visit, right? So we would need to do another linear loop, right, to find which employee, right, which employee has an ID of 2, guys, right? And then get reference to it, and then be able to do the same thing, right, for 3, because we don't have reference to that, right? We have those integer values, right? So we need to do some pre-processing before we get or the algorithm, right? Go like continue with the algorithm, right? So what we need to do, right, is to maybe put in some sort of a data structure that can help us to easily find access to that employee, guys, right? We can just do a linear loop before to create that data structure, and to create that structure that's going to contain the information, right? And then reference it when we need to know. So when one needs to know, all right, which visit employee with employee ID 2, right? I can easily just refer to that structure and get that employee and be able to capture its importance and visit any subordinate that it has, right? So you might be thinking of a map, guys, right? We're going to be mapping every employee, right? Its ID to the actual employee node, guys, right? So we have reference to that, okay? So that's kind of what we're going to be doing, guys. Let me know if it makes sense. So the map is going to contain that. So integer, right? Because without the map, we would need to do a linear search, guys, to find that employee, guys, right? That has that ID, okay? That's kind of why we decided to do it like that, okay? Doesn't make sense, do let me know in the comment section, guys, right? So I can improve and do better next time. All right, so that we create our map, guys, right? Our map. Okay, so now we're gonna just start off, do so for each employee, right? Visit, gonna add it to our map, guys, right? So map that put, so we're gonna be putting the ID, right, to the actual employee node, guys, right? So once we have that, we're pretty much in the clear. We can return our DFS that we're going to be building, guys. What do we need? We need just a map, right? And also we need the ID of where we need to start with, right? So this is the starting node, guys, pretty much, right? So, and yeah, because we're given this ID because it tells us, we're like the employee that they need the importance, the total importance, right? Okay. And then our function is going to be very simple. DFS. We just copy that. And what else do we need? We also need the ID, right? Okay, so now that we know we created our map, right? I already explained why we need that, right? So we could easily have reference to an employee, right? And then once we get to a particular whatever particular node, we just do employee, right? Do map that gets ID, right? So we get that employee, right? So we get the employee that we want, right? Which is 1, for example. So we get that node, right? And then we have a count, guys, right? A count start off by this employee's import, right? Let's start with that. Okay. So we get its points, and then now, okay, we visit any of our subordinates if we contain subordinates, guys, right? Okay. So we're going to be employee subordinates. Okay, so for all my subordinates, right, which is can be obtained by emp dot subordinate, right, and it's not employee, right? It's subordinate ID. Okay, so we get the IDs, right, because it's a list of integers, right, and then we just do count, just append to just add to the sum, right, to the running sum that we're building, and we pass in the map, right, so that it could get reference to it, and then we pass in the subordinate ID, right. For example, we just put in points of 5, right? We store in this variable, and then we visit all of one ID1, right? The employee ID1, all of its subordinate, right? So we start off with 2, for example, right? And then we pass in the map, and we pass in 2, right? And then it calls this function again, right? It's a recursive function. Recursively keep doing that, right? And then 2 comes here, and then we get its node, right, from the map, and then gets its count, right, which is 3 at this node. And it doesn't have any subordinate, right? And then it just returns the count guide, right? As simple as that. Okay, that this thing works, it looks like. So that's pretty much code. We said we will need to create a map of ID to employee, right? So could easily have reference to it, right? Be able to get the particular node for this ID, right? And O1 instead of doing a linear search every time to find the node in the list, right? The index in the list that correspond to that employee ID, right? So that's what we did that, and then we started a depth research for each node. We get its importance value, and then also try to obtain the total importance value of all of its subordinates, right? If there exists, right? And then return the count to the color and like that. Let's press submit, see if we pass all the test cases. Awesome, guys. We're able to pass all the test cases, guys, right? If you guys understood the thought process and it made sense to you guys, let me know that in the comment section. If you're new here, make sure to subscribe because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.